Hello guys, welcome back to another lecture in this course. So in this lecture, we are going to discuss about the mathematical functions that are normally helpful in data science. So in this video, we'll be talking about a linear function. Math function helps in working predictions and the data interpretation after predictions. Linear functions helps to relate a variable to another variable. We have what we call independent variable, and also we have what we call dependent variable. An independent variable, it is a variable which does not depend with anything. It is full and complete on its own. It relies only on its own data. That is an independent data or independent variable. And we have what we call a dependent variable. These variables, they depend with the other elements or other input. For example, if you are to compare a plant growth or a plant, so the plant growth depend with the two variables. So the plant growth is a variable, but this variable, it is a dependent variable because a plant grows faster in a warmer temperature. So it means that the temperature is an independent variable. Hence, the dependent variable is the plant growth. So for the plant to grow faster, it depends only with the temperature. And if you are to give another scenario where we are having dependent and independent variable, it will be maybe in traffic issues. For example, let us say you are driving in a highway. So how do we measure the mood of people on the highway, the mood? So the question would be like, to what extent does traffic affect the person mood? So we discover that now the traffic is an independent variable. The mood now will depend with the traffic. If there is a traffic jam and you are in a hurry, then the mood will differ. So there are a lot of things that can trigger the mood along with regard to traffic. So you discover that the independent variable is the traffic and the dependent variable now is the individual mood. So the relationship between a dependent and independent variable can be expressed mathematically using mathematical formulas. I believe in mathematics we have a formula which helps us to derive a linear equation or to draw a straight line on a Cartesian plane. For example, we normally use y is equals to mx plus c. This is a simple version, a simple linear equation. We are saying y is a dependent variable. Now x is an independent variable plus c the constant. So in this formula, in data science, we use y is equals to fx, which is equals to ax plus b, where f of x or the function of x is equals to ax plus b. So a linear function is one independent variable, which is x, and also one dependent variable, which is y. So this function is used to find the value for a dependent variable when we choose the value for the independent variable, only after choosing the value for independent variable. So in this case, we are saying in our equation, y equals to f of x is equals to ax plus b, or f of x is equals to ax plus b, or y is equals to mx plus c. We are saying f of x represents the output, the dependent variable, and x is the input, that's the independent variable, the input, and a or m represents the slope or the gradient, or we can say is the coefficient of the dependent variable. So the dependent variable coefficient, we will put it on a. So the slope now, it tells us the rate of change of the dependent variable. How the dependent variable changes, it depends also with the slope. C or B, this represents the intercept or the value of dependent variable. So this intercept only happens when x is equals to 0. So it is also the point where the diagonal line crosses the vertical line, or is when the linear line, the linear programming line, or the slope cuts across the y-axis. At that point, it is when x is equals to 0. Okay, I think this is all for this lesson. Thank you for watching. See you on the next lesson. Bye-bye.